The first four Hermite polynomials are 1, 2t minus 2 plus 4t squared minus 12t plus 8t cubed. Okay, and these polynomials arise in math physics. We need to show that these first four Hermite polynomials form a basis for P3. Okay, this notation P3, that's the polynomials set of all polynomials up to degree 3. Okay, we know that dimension of this vector space, okay, up to degree 3, that's 4. 3 plus 1, 4. And we know that the standard basis for P3 is 1 t square, because this is up to 3, and t cube. Okay, from this we know that the dimension is 4, and here we got 4 members. Okay, these Hermite polynomials, these are 4, so the dimensions match. So all we need to show in this case is these elements or these vectors in the context of a vector space, we can call them vectors. We need to show that these 4 polynomials are linearly independent. That's it. That would be enough, because the dimension of this is 4 and we got exactly 4 elements. Okay, so I'm gonna write this. It's enough to show that the given polynomials, 4 of them, are linearly independent since the dimensions match. For we write a linear combination of these 4 polynomials going to 0. So let's say c1 first, 1 plus c2 second, 2t plus c3 third, negative 2 plus 4t squared plus c4 times the last, negative 12t plus 8t cube equals 0. So from this, if we are able to show the only solution is c1 0, c2 0, c3 0 and c4 0, that makes these 4 vectors or these 4 polynomials linearly independent. So let's simplify here. We can distribute, then there is a c1, that's the constant, and when we multiply, here is c3 times negative 2, negative 2c3, negative 2c3, so that's a constant, plus, now I'm looking at the terms containing t. Here is t and here is t, so 2c2 and here is negative 12c4t, so negative 12c4 plus, now let's look at the terms containing t squared. So here is t squared and that's it. Okay, so I don't need this, that's the 4c3t squared, and here is the last is t cube. Okay, c4 times 8t cube, that is plus 8c4 t cube equals, we got 0. Let's look at the constants with t squared and with t cube. So we have 0. This 0 can be written as 0 plus 0 times t plus 0 times t squared plus 0 times t cube. Okay, so that we can match this constant should be 0, because we are saying the left hand side is equal to right hand side. So, and this, the coefficient of t should match with this 0, and for t3 should be 0. In the same way 8c4 should be 0. So you got the idea here. Okay, so this implies c1 minus 2 c3 0, 2 c2 minus 12 c4 0, 4 c3 0, 8 c4 0. Okay, now this implies, let's solve from the backward. 8 times c4 0, so from this one divide by 8, so we get c4 0. Okay, from here, then from this one, what is c3? 0. Now when c3 is 0, okay, c3 is 0, then c1 is 0. And from here, when c4 is 0, because we saw c4 is 0, then c2 is 0. Thus we got c1, c2, c3, c4 all going to 0, and that's the only solution. That means the polynomials are linearly independent, and we are done, because the dimension of the vector space is 4, and we got 4 vectors or 4 polynomials. Thus the polynomials, the given 4 polynomials, are linearly independent, and hence they form a basis for P3.